Hello everyone, welcome to Geo-Rant 157. There's the title, the date, We Like Us. You might be being like, that's a really weird title. And then you see all these numbers and you're like, this doesn't make any sense. But before I get into why I named this, I'm gonna go over this really quick. But first of all, this is gonna be a straight shot, unedited, as most of my Geo-Rants are, unlike the last one. So if I trip and stumble, I apologize. These statistics here were taken from online basic internet searches. Since I live in the US, my searches are biased towards the US. I don't have time to go through every list of every country and come up with lockdown numbers. These are estimates and they are rough, but the numbers don't matter as much as the ratios do, and I'll talk about that here in a second. So, number of archaeologists in the USA, it's about 7,600. What do I mean by that? I mean degreed archaeologists, people who do archaeological things, stuff like that. There's about 7,600 of them. Now, geologists, there's about 32,000 of us. It's a lot more than this. Now, the title has something to do with how we're attracted towards things like us, but archaeology is us. It's about us, our history, our past. Geology isn't. So there's a lot more geologists than archaeologists. Well, if we like things like us, why are there more of these guys? Well, that's where this comes in. Because geology, you can get a degree, work in geology, whatever, because geologic principles help you find water. They help you find oil. They help you find silver, gold, copper, etc., etc. And there's a lot of people who do that, and that's all they do. They don't teach. They're not in academia. They don't write papers. They don't put things in journals, they don't write books, or they don't go on field trips. They go in, they punch a clock, they do their job, they go home. All right, and then they forget about it. That doesn't mean they aren't good at geology, it just means that's what they do. That's what I mean by professionals, and I'm pulling them out. There's about 13,000, there's about 13,600 left after I do that. If you want to figure out the number, just add, you know what to do. All right, now, out of these 13,600, these are the academics, or the people that don't do geology for a living, but have a degree in it, and for whatever reason, they can't work in the field, but they are active in it. They go to seminars, they go to like GSA memberships, stuff like that. They do side work, write in journals, publish in journals, things as such. There's about 13,600 of us. But you take all the ones out that don't study the Precambrian, and there's only about 800. That's a lot less than this. Why is that? Well, this comes back to we like us. What do I mean by we like us? And I've already touched on it. We like the things humans do. We know the things humans do, and I'm not going to get into a cultural argument or anything like that. There are basic things all humans do regardless of our culture. We laugh when we're happy, we cry when we're sad, we grieve over loss, etc., etc. You get what I mean. And we as humans can tune into that even in an archaeological record sometimes, okay? So we do really well with very familiar things. We don't do well with unfamiliar things. And, and that can include the world around us. When we see trees grow, we know how to farm, stuff like that. So it extends to the natural world we recognize as well. That's why there's under 13,000, 12,800 geologists that study the Phanerozoic, 541, the beginning of Cambrian, 541 million years ago to today. That's less than 12% of Earth's entire history, where nearly 13,000 geologists study. Why is that? Because that's the time of macro life. That's the time where we see trees appear, fish, dinosaurs, mammals, things we're familiar with, grasses, flowers, although that's later and the Mesozoic, but still, as you go further back in time, it becomes less familiar to us. And, collecting fossils is cool. People like to do it, and that's fine, that's great. Studying them is cool. More power to you. But you go back into the Precambrian, you go back into that greater than 88%, and the world starts to become very unfamiliar to us. Yes, there's oceans. Yes, there's continents. but there's nothing on land to anchor down any soil. All soils at this point are chemically derived. There's no land life. There's no sea life other than stromatolites. When I say life, yes, I know there's little things in the atmosphere, single-celled life everywhere. But from a rock record, the only thing we can recognize in the field are these stromatolites. So there's no cool fossils. You're not going to stumble onto a T-Rex or a trilobite or anything like that because they weren't there. They hadn't evolved yet. So we can't use index fossils to date things in the Precambrian either because they're just not there. We have to rely on radiometric dating to get absolute dates. Well, you can't absolutely date sedimentary or metasedimentary rocks, which are the Precambrian rocks I study. You only get detrital zircons. Now, the thing about that is this leads to a lot of people being discouraged from studying the Precambrian. No, there's no fossil. I want to play with coal forests, or I want to play with trilobites, or I like woolly mammoths. That's fine, cool. You do you. But the Precambrian is the big chunk. It's the big daddy. And if you're good at structural geology and stratigraphy, and especially igneous metamorphic petrology, you want to do the Precambrian. That's what you want to do. Let the other guys, let the 13,000 other people handle this, all right? Because in the Precambrian as well, the further we go back in time, the rocks tend to become, the record is more sparse, but it generally, there's exceptions to that, but the rocks tend to be more deformed. They tend to be more structurally complex. And since we don't have fossils to date stuff, we have to rely on stratigraphy a lot of times, talking about metasedimentary rocks. I mean, obviously you can directly date igneous rocks. So we have to rely on those techniques more than what we would in the Phanerozoic. You're going to be hard pressed to find Precambrian geology, which is taught later, which is in the field, layer cake geology, which everyone is taught in 101. It's not like that, the Precambrian anymore. Plus, things were very, very different. Things are very different than they are now in the Precambrian, the further you go back. We didn't have a lot of oxygen in the atmosphere then. We didn't have any until 2.5 billion with a B years ago. We had a lot of CO2. We had no plants to anchor down land. Erosion happened faster. We had processes that no longer in operation today, like Earth is no longer producing comiotites. I can never pronounce that. I'll put it in the description, the actual spelling of it. Earth no longer makes ozons or Archean. Earth no longer makes banded iron formations. These things we are completely unfamiliar with. We have no direct comparison. And some of you heard me talk too. Plate tectonics probably wasn't in operation in the Hadean and Archean either. So the things we're familiar with, the things that are around us today, were not there. This makes figuring out anything very difficult. You have to have more of your ducks in a row to present evidence and form a hypothesis than you would in the Phanerozoic. All right, and plus Precambrian exposures in North America anyway tend to be in very polar environments, places people don't like to go anyway. There are exceptions to this, like the Ozarks in Missouri and the Snowy Pass group out in Wyoming, things like that. But the vast majority of it's on the Canadian Shield. So I like studying things that are not easy to figure out. I like studying things that I am not familiar with. I mean, I can go outside and look at a tree. I can go outside and watch something crawl on the ground. I can go outside and breathe the air. I know this sounds like I'm dissing something, but I'm not. I'm not dissing any of that. People need to study that, but the Precambrian is where all the mysteries are. That's where all the groundbreaking stuff is going to be, for the most part. There's so many open-ended questions in the Precambrian that just aren't there in the Phanerozoic. So that's what I mean by we like us. We gravitate towards things we can relate to, things that are familiar to us. And that's just a human thing. And it's hard to break away from that. I, for a long time, studied Quaternary glacial deposits, and then I'm like, you know, everybody out here does this. I want to study rocks nobody else does. And I'm really good at structural geology. So that's when I started doing the Precambrian. Anyway, that's it. If you have any questions or comments, please leave them below. And as usual, I hope you guys did learn something.